Okay, this video is going to be about protein absorption. So recall that protein digestion starts in the stomach, and we're talking about chemical digestion, starts in the stomach with pepsin. So pepsinogen comes from the chief cells and reacts with hydrochloric acid and becomes pepsin and breaks down proteins into smaller polypeptides. Those polypeptides go into the small intestine where they're broken down further through enzymes secreted by the pancreas. Okay, so I'm going to draw my little cell. So here's the top of my cells. Cell wall. Here's the basolateral membrane here. Up here's the lumen of the small intestine. Right, and a little blood down here, capillary. All right, so along the top of the cells, these are the enterocytes. Okay, they're basically simple columnar cells. They line the small intestine. This is microvilli. Okay, and along the microvilli, the microvilli has a special name called the brush border. And the brush border has enzymes, peptidases, that break those peptides or polypeptides down that have been broken down, and breaks them down into the smallest particles. Okay, so they get broken down into tripeptides, dipeptides, and amino acids. And these two things go in, I did this separately, amino acids over here and the tripeptides and dipeptides over here because they go into the cell a little bit differently. So the amino acids go into the cell a lot like glucose and galactose. So there is a transporter on the membrane and it will allow sodium. So sodium is out here in the lumen. It's outside of the cell. And as sodium goes in, that allows for the amino acids to go in. So very similar to the way the glucose and the galactose got into the cell. On the other side of the cell, of course, we have our sodium-potassium pump. And that will keep the gradient for sodium going. So it will keep sodium flowing in. Okay, so we have sodium coming in the cell and then being pushed back out of the cell by the sodium-potassium pump. And along with that, we have potassium coming in. Okay, works the same way as the glucose and the galactose. Now the tripeptides have a little bit different of a way to get into the cell. And there is a transporter. Move this over and just leave it up. Oh, don't go away. Okay. All right, sorry. So there's a transporter on the cell. And again, it allows for sodium to move. And the sodium in this particular transporter, which is a co-transporter, it will allow sodium to come in. So here's sodium. And in exchange for that, it goes in reverse. It will allow for hydrogens to pump out. So as that's happening, basically a gradient for hydrogens is being created here. Okay. Again, the sodium is still going to continue to move because it gets pumped out by the sodium-potassium pump. There's another transporter on here that allows for the hydrogens to move back into the cell with their gradient, creating a movement, a gradient movement, and with that comes the dipeptides and the tripeptides. Okay, so just a little bit different. On the PowerPoint that we have, there's one of the examples on there. It only shows the movement of amino acids. It doesn't show the movement of tripeptides and dipeptides. Once those molecules are inside the cell, there's a transporter down here that allows those molecules to go into the bloodstream. So we've got these guys here and the amino acids. All right, and then they go into the blood and they are off to the liver. Okay, so very similar to carbohydrate absorption, both of these molecules go right into the blood from the small intestine. And then from the blood, they go to the liver, from the liver into the circulation. Okay, so the next video we're going to do, or I'm going to do, is going to be about lipid absorption.